Right. Now we are going to start the environmental chemistry part. Right. So if you come to environmental chemistry, so we are learning about two main topics. There are two main topics. The first one is the air pollution part. The second one is the water pollution part. If you come to air pollution part, we are learning about these topics. We are learning about the gases causing the air pollution as the first topic, gases causing the air pollution. Second one, acid rains. Third one, global warming and greenhouse effect. Fourth one, ozone layer depletion. Last one, photochemical smoke. Right? So today we are going to learn about the acid rains. Right? So like this I am going to discuss the rest of the topics also. Right. If you come to acid rains, before going for that, so first of all tell me, so if you come to the air pollution, so you know that air pollution can be caused by three types of gases. Three types of gases. Right? Air pollution can be caused by three types of gases. First one is, what's the first one? Inorganic gases. Inorganic gases. Example, noxus. Noxus means NO and NO2. SOx, SOx, SO2 and SO3. Ozone, carbon dioxide, carbon monoxide, H2S. So these gases are inorganic gases. They are causing air pollution. Next one. Organic or hydrocarbons. Hydrocarbons like CH4 and unburnt hydrocarbon produced during the internal combustion of the vehicles. Right? That is the second one. Inorganic hydrocarbons. Last one, hydrocarbons like CFC. Right? Then HFC and HCFC, like that. There are a lot of hydrocarbons also causing air pollutions. Right. Today we are going to talk about the acid rains. So if you come to the new syllabus, so they are talking a lot of things relevant to the acid rains. Right. If you come to the acid rains, so if you take the normal rainwater, so we are coming here. So if you take the normal rainwater, its pH is around 5.6. 5.6. Why? The reason is carbon dioxide gas is dissolved in rainwater to form H2CO3 aqueous. Carbonic acid. You know that a carbonic acid is a weak acid. So it partially dissociates into H plus and bicarbonate ions. Because of these H plus ions, the pH of the solution drops up to 5.6. 5.6. This is the normal rainwater. That's the first thing that we should know. Then, if the pH of the rainwater is less than 5.6, if the pH of the rainwater is less than 5.6, because of the strong acids, rainwater can mix with strong acid. Because of these strong acids, pH will be less than 5.6. So it becomes acidic. So that rain is called acid rains. I think you can understand this one. Right. Then, so what are the gases cause the acid rains? That is the third thing that we are going to discuss. Second one and the third one. So I don't have enough space in this board. That's why I'm writing it like this. Right? You can make a short note for this one in a proper way by using a paper. Right? So if you come to the gases causing acid rains. So what are the gases causing acid rains? Noxus, mainly noxus and SOxus. NO, NO2, SO2, SO3. These gases causes acid rains. then you should know the way that these gases entering into the environment. Right. It can be entering into the environment in two different ways. Right. Can be entered to the environment in two different ways. First one is the natural method or natural ways. So under that I'm going to talk about 1, 2, 3, 4 methods. Right. So if you take these gases can be entered to the environment using these methods. First one is, you know this one, during the lightning you know that huge amount of energy is released. You know that nitrogen gas has a triple bond with a higher bond energy. This bond is breaking due to this high energy and it reacts with oxygen to form NO gas. It further oxidizes with oxygen forming NO2 gas. It further oxidizes. That is the first natural method, that the noxus entering into the environment. Next one, volcanic eruption. So during that, you know, the noxus as well as sulfur containing compounds can be produced, right? Then nitrifying bacteria can produce noxus. Volcanic eruptions, nitrifying bacteria, and you know that due to the anaerobic decomposition of nitrogen containing waste materials, ammonia gas is produced. That ammonia gas can be further oxidizes to noxus. So these are the 4 main methods. You should remember these ones. 1, 2, 3, 4. This is the first thing that we should know, this is the second thing, and this is the third thing that we should know, and this is the fourth thing that we should know. What is that? The natural ways that these gases entering into the environment. Next one, you know that these gases can be entered to the environment due to the human activities. So these methods are, or these natural methods are, it means during these methods noxus and success enter to the environment, but it is not in huge amount. So we know that these methods must be present in the environment to maintain also. For example, if you take nitrogen dioxide, so it is dissolving in water and comes to the environment, also comes to the ground. So it provides the nitrogen to the plants. You know that naturally it's occurring, right? Naturally occurring, and we know that we need these ones. But if due to the human activities, these noxus and soxus amounts can be increased, right? So what are the methods that the noxus and soxus enter to the environment? So these are the methods. First one is the fuel burning, right? Fuel burning, or burning fossil fuels. When the fossil fuels are burning, you know that. So mainly less volatile diesel and furnace oil. So when they are burning, noxus and soxus enter to the environment. Right? So these fuel can contain sulfur, right? So when we are burning it, it produces sulfur dioxide and sulfur trioxide. Second method is, so you know that if you take coal power stations, they are using coal, and we know that contains FeS, iron sulfide. And when we are burning this one, in Sri Lanka also in Noracholi, we are using coal as to generate the power. So when we are burning this one, it contains these sulfides and it produces sulfur dioxide and sulfur trioxide, right? And also when we are extracting metals, sometimes we are burning this one, or FeS, so it also can produce sulfur dioxide. That is the second method, fuel burning. Second one is coal burning, right? When we are burning the coal. Third method, if you take cigarettes, and when we are burning woods and gas stoves, so if you are using these ones, or we are burning cigarettes and these ones, it produces NOxes. Right. This is not relevant to this one. This is relevant to the next topic, this part. And these are the methods that the SOxes and NOxes enter into the environment. Okay, finish. Right, then the effects. The effects are also very important. The effects are also very important, right? Effects. Before that we should come to the reactions. I forgot that. Right, reactions. It's here. Reactions. Right. During the combustion, internal combustion of, when we are burning fossil fuels, if it is containing nitrogen, right, it reacts with oxygen to form NO gas. NO gas. When you are starting the engine, so huge amount of energy is released. By using that, nitrogen begs to form NOxes or NO. It further oxidizes to form NO2 gas. This NO2 gas reacts with H2O liquid with the rainwater. This is the rainwater, right, in the presence of oxygen, and further oxidizes to HNO3 aqueous, nitric aqueous. That's the first method or the first reaction, right? Second one, SO2, sulfur dioxide, reacts with oxygen gas to form sulfur trioxide. Right, sulfur dioxide forms sulfur trioxide. That sulfur trioxide reacts with H2O liquid to form H2SO4 aqueous. Right, can be further oxidized with oxygen like this. It means the reaction can take place like this also. SO2 gas can react with H2O and oxygen to form a strong acid, sulfuric H2SO4. H2SO4. I think you can understand. So these ones, HNO3 and H2SO4, we know that they are fully dissociates to form H+. Right? Fully dissociates to form H+. So the pH of the rainwater drops and forms the acid rains. Okay? Right, that is the reactions. That is the fifth thing that we should know. Right? First one, fifth one. 1, 2, then 3, 4, 5. Now we are coming for the sixth topic, that is effects. Effects. So you know that if you take rainwater, if it is acidic, so it causes destruction of aquatic organisms. They are very sensitive organisms, right? Due to the lower pH values or due to the high acidity, its eggs, it means, or directly the fishes can be died or plants can be died. So we have small plants in the aquatic environments, so they are dying. That's the first thing that can happen, right? Second one, death of coral polyps, right? Because of that, you know that the coral reefs can be died, right? So they are also very sensitive to acidity. Then degradation of chlorophylls. So the plant leaves contains chlorophylls. So because of the acid rains, the plant leaves or the chlorophylls can be damaged. Because of that, the plant will die. So that is the third thing, the third effect. Second one, third one, and then we are coming for the fourth one. What is that? You know that acid rains contains a relatively high amount of H+. Because of that, it increases the soil acidity and decreases the pH value of the rainwater. Right? Because of that, these ions will comes into the, or these ions which are bound to the soil can replace, and then it comes to the water, right? Then what happens? Due to these ions, aluminium 3+ and Fe3+, aquatic animals can be died or damaged. Aquatic environments can be damaged. Then these ions, Fe3+, Zinc2+, and Copper2+ ions cause the soil infertile. Right? Infertile. Then dissolved rocks. It can dissolve rocks. You know that, right? Rocks containing calcium, magnesium, and aluminium salts, or they are dissolving and calcium, magnesium and aluminium ions comes to the water, and hardness of the water increases. Hardness of the water increases. That is the fourth effect. Fifth one, corrosion. Corrosion, right? So metal structures, we know that these acids can damage the metal structures. Metal statues and buildings, structures can be damaged, right? The sixth effect is, so we know that limestones and marble contains calcium carbonate. Limestones and marble contains calcium carbonate. So it can be dissolved in acids, you know that, right? It can be dissolved in acids. Seventh effect, it's here. Seventh effect. Seventh effect. It is converting the less soluble carbonates in mortar and cement into soluble ones. Soluble ones. And they damage the structures, the cement structures also. And these are the effects caused by the acid rains. Acid rains. Right? Finally, so how we are minimizing these ones? How we are minimizing these ones? So also very important. So when you are writing the short note, you should write. I'm going to your resource book. That is page 62. This is page 62. In that one, there is a reaction, right, relevant to this one. Calcium carbonate reacts with sulfur dioxide, oxygen and water. Calcium carbonate reacts with sulfur dioxide, oxygen and water, forming calcium sulfate dot 2H2 or gypsum plus carbon dioxide. So they are soluble, right? Or the calcium carbonate soluble like that, or will be dissolved like that. Okay, you should remember that equation also very important. Then how we are reducing the acid rains. So these are the things that we can do. First one, you can use coal and diesel with low sulfur content, right? So we can, you know that the coal, when you are burning coal, sulfur dioxide mainly form, and we can use the coal and diesel which is not containing sulfur. That is the first method, or the first thing that we can do. Second one, so you can remove the acidic gases, right? For example, calcium carbonate produces calcium oxide when we are heating, right? It produces calcium oxide. That calcium oxide can be reacted with sulfur dioxide and it forms calcium sulfide solid. So like that you can remove the sulfur dioxide. Calcium oxide plus sulfur dioxide goes to calcium sulfide. You can remove the sulfur dioxide. Another method is you can use calcium hydroxide, and calcium hydroxide reacts with sulfur dioxide to form calcium sulfite and water. Like that also you can remove sulfur dioxide. Third one is you can use environmental friendly fuels and alternative energy sources. So there are a lot of alternative energy sources. Without using the fuel, we can use them. In Sri Lanka, we can use sunlight and the sea waves, wind, but we are not mainly using them, right? Then, so they are giving some energy sources: solar energy, wind power, tidal energy, geothermal energy, nuclear power, right? So you can use those methods to minimize the production of acid rains, right? So these are the main important things, and I want to tell another thing, right? To minimize the formation of NOxes, you know that the catalytic converter also can be used. Carbon monoxide and nitrogen monoxide produced during the internal combustion forms nitrogen and carbon dioxide when we are using a catalytic converter, right? So like that we can minimize the acid rains. Thank you.